Greetings. Let us continue with the part of discussion related to dynamic formulation. In last lecture, we have seen about the engineering news record formula, and we have also started with the discussion of Haley's formula. In Haley's formula, what we have seen, the Haley's formula account for the energy losses in the application of the hammer, and it modifies the engineering formula. And this recommendation was been accepted in IS 2911, and the determination of the ultimate load pile capacity is given by the empirical relation QUP is equal to neta H into neta B WH divided by S plus C by 2. Neta H efficiency of hammer is given for a drop hammer, it is taken as 1 is 100%. For single acting pressure hammer, it is ranging from 0.25 to 0.85, and for double acting pressure hammer, it is varying from 0.2 to 0.8. Now neta B, here neta B is defined as the efficiency of hammer blows, which is defined as the ratio of energy of hammer after the impact to the energy of the hammer before the impact. To account for this neta B, the formulation is given as W plus E square into P divided by W plus P, where W is nothing but the weight of the hammer, E is nothing but the coefficient of restitution depending upon the material type and the material surface character, and P is the pile weight of the pile. If when weight of the hammer is greater than the product E into P, then this formulation is being used. When it is less than or equals to this, then we are going to modify the coefficient with formulation like W plus E square P divided by W plus P minus of W minus E P divided by W plus P whole square. Now for defining C value here, the elastic constant which accounts for the elastic compression of the pile, it has been divided into three component parts. One take care for pile type, the second take care for the soil type, and the third take care of the pile cap. Now let us talk about the pile cap here. When we are going to say the column is being supported by n number of piles, this n number of piles are being connected to each other to form a surface where the seating will be formed for the columns to be erected above it. That particular portion is called as a pile cap. So here pile cap is also considered, the characteristic of pile cap is also considered to estimate the value of elastic constant, which accounts for elastic compression of the pile. Okay, so C is equals to C1 plus C2 plus C3. Now this C1, C2, C3 has their individual relationship with reference to the character of the pile and the character of the system of hammering here. So when driving without a dolly or helmet and a cushion of 2.5 centimeter thickness is there, C equals to 1.77 QU by A, where here the dolly or helmet is the uppermost part, where the uppermost part of the pile head, where it receive direct the drop hammer load. So if the cushion is about 2.5 centimeter without any provision of dolly and helmet, the coefficient will be defined as a single value, C equals to 1.77 QU by A. When it is being provided with short dolly or helmet and cushion over it up to 7.5 centimeter, then the C1, C2, C3 value will be calculated separately with reference to the pile, with reference to the arrangement, dolly and packing arrangement, and with reference to the ground characteristics. Let us talk about what is the meaning of a dolly here. Dolly is a cushion of a harder wood or other material placed on the top of the casing to receive the blows of the hammer. Means it is provided in respect to have protection over the head of the pile. If directly the hammer strikes on the head of the pile, then there may be chances of the head get damaged. So to avoid this one, a hard packing of wood is being placed over it, and that packing is called as a dolly. Sometimes what happens, the blow is very much heavier. So to secure dolly in position and to secure the head against crack, we are going to provide a cage around it, or a temporary steel cap around it, which will protect the head as well as which will form the sitting for the dolly. That is called as a helmet. Okay, the upper portion of that helmet is dolly, and the lowermost portion we are calling it as a jacketing. Sometimes what happens, the hammer is not being directly strike on the head, it is at a certain distance away from it. Then in that case we are going to provide an extension to the hammer piece towards the helmet piece, and that extension we are going to call it as a follower. And this follower may may have a large grip length, that's why we are going to call it as a long dolly. Let us go towards the tabulation which is given below in PPT. This tabulation says about the value of coefficient of restitution. This coefficient of restitution directly depends upon the type of the head where the blow is being received. It's nothing but the rebound of the hammer after striking. So here it is a measure for the loss of energy. So what we are going to see how it can differ with reference to the system which the head hammer resisting system has been provided over the head. The steel ramp of a drop hammer striking on a steel anvil, then it is said to be 0.5. When we are going to use cast iron ramp or drop hammer stacking on the head of RCC5, we are going to consider this E value as a 0.4. When we have the single acting steam hammer or a drop hammer on the head of the pipe, then it is 0.25. And in case of deteriorated pile, means where there is damages, pre damages to the head, and we are just keeping this pile as a duty pile. It is not going to take any part related to structural load transformation. It is just to have a supporting system. In that case, we are going to say it as value is E is equals to 0. Now let us talk about the efficiency of the hammer. The efficiency of a hammer depends upon the type of hammering system which we have provided in while driving the pile. So they are trigger operated drop hammer, they are winch operated drop hammer, single acting steam hammer, Macronan Terry type double acting steam hammers. So in case of trigger operated drop hammer, we consider it's 100% efficiency will be there. The hammering efficiency will be there. In case of winch operated drop hammer, it is 80%. In case of single acting steam hammer, it is about 90%. And in case of Macronan Terry type of double acting hammer, steel hammer, it is going to be 90%. One more formulation has been come with the name as a Danish formula. In this formulation, the basic theme is the same. The product WH neta H divided by S plus C by 2. It is similar as that of defined in terms of Hilly formulation, but what here the change is that the elastic compression of the pile is being taken into care. So instead of going for the character of the soil, instead of going for the characteristics of the piles or the piling, the materials which is the resisting materials is directly related to towards the pile material itself. So C is equals to under root of 2 neta H W small h into L divided by AE, where 2 into this is a 2 is a factor which enhance the value. Neta H nothing was the efficiency of the hammer. W is the weight of the hammer here. Small h is the height, free fall height. Small L is nothing but the length of the pile. A is the cross section area of the pile, and E is the modulus of elasticity of the pile. In the case of Danish formula, he has recommended a factor of safety to be used is in within the range of 3 to 4, while if we see towards the Healy's formula, it is recommended the value between as factor of safety as 2, and for engineering news record formula, the factor of safety was recommended as value was recommended as a 6. Now let us talk about the limitation of dynamic formulation. Though these are the empirical methods we are going to relate with reference to the character and hammering system, but somewhere there is a certain limitation to this one. So very first one is that ultimate load computed from the dynamic formula represent the resistance of the ground to pile driving, but not the static load capacity of the pile. Means they are not going to say about actual capacity of the pile, but they are going to relate with reference to the resistance which is offered from the ground itself. When piles are driven through saturated fine sand, the pore pressure developed reduces the load capacity of the pile by as much as 44% in the engineering's new formula. Means what? When the soil character is being deferred, if there is a water saturated soil, then there is a pore pressure which is going to act, and thereby it reduces the load carrying capacity of the pile, which was not been accounted anywhere in your dynamic formulation. Thus, dynamic formula are suitable only for coarse sands where pore water drains out without development of pore pressure. So, this dynamic formulation is not valid for the soil which are having saturations. Okay. When piles are driven through cohesive soils, the skin friction resistance is reduced, the end bearing resistance is increased. Thus, the dynamic formula do not represent static load capacity for cohesive soils and hence are not suitable for such soils. So, this type of formulation is not suitable for the the soils which are cohesive soils. There is uncertainty over the relationship between the dynamic and the static resistance of the soil. So there is a lot of ambiguity, uncertainty, or there is no direct relationship between the dynamic character and the static characteristics or resistance of the soil. The law of impact used in dynamic formula for the computation of load capacity is not strictly valid for piles subjected to restraining influence of the soil. Means this is we call it theoretically it is good, but when actually it is implemented, we can't say there is a direct relation. Such direct relation we can have uh, with reference to the soil and its character. The group action and reduced efficiency of the pile group compared with the sum of the individual load capacity of the pile in the group are not accounted for in dynamic formula. Now it's very clear that it can be applied for a single pile and the estimation is very good for that. But when the group is being going to be asked, group of pile is going to have a group action for the load applied on it, then in that case this action is not being clearly represented by the dynamic formulation. In engineering news formula, the weight of the pile and its inertia effects are not considered. It is difficult to estimate the energy losses due to vibration and damage to the Dolly or packing accurately, and consequently it results in the error in the computed load capacity of the pipe. Yes, there is an uncertainty related to the damages which are observed with shock resisting elements like Dolly or packing, and thereby it may have certain uncertain results. Now let's go towards quickly we'll go towards some numerical which are based on the dynamic formulation. So it is quite a bit easy compared to the static formulation where we have to take certain coefficient under consideration, certain assumption under consideration. Here empirical formulas are given to you directly. You are going to put up the values and get the results. Now let us say let us move towards the numerical number 1. A wooden pile is being driven with a drop hammer weighing 20 kilonewton and having a free fall of 1 meter. The penetration in the last 5 blows is 5 mm. Determine the load carrying capacity of the pile according to the engineering news formula. So here direct statement is being made. A wooden pile is there which is being driven with the help of a drop hammer. The hammer weight is given to us. The free fall height of the hammer is also given to us, and the penetration which is observed by the pile in last 5 blows is also accounted and is given to us, and we have to simply fit up this given data into the formula and get the capacity of the pile. So QUP is equal to W into H into neta H divided by F in bracket S plus C. This is the engineering news formula which we have learned in previous article. So here W is the weight is given to us, weight of the hammer which is given to us is 20 kilonewton. For drop hammer efficiency is about 0.9, which was recommended by the engineering news record formula. H is the free fall height which is given as 1 meter, but the formulation is in the formulation height is considered in terms of centimeter. That's why we are going to consider this height in terms of centimeter, 10 centimeter. The factor of safety for the engineering news formula it is about 6. So we will use F equals to 6 here. Yes is the settlement, the observed settlement here. The observed settlement is about 5 mm. We will convert this into centimeter. It is about 0.5 centimeter. Now capital C is the coefficient related to elastic compressibility of the soil. So in case of drop hammer, the coefficient C is recommended value is 2.5 centimeter. After substituting this all values in the equation, we get 20 into 100 into 0.9, 20 the weight of the hammer, 100 the free fall height in centimeters, and neta H in terms of efficiency 0.9 and divided by 6 factor of safety 0.5, the settlement value which is given to us, and 2.5 the coefficient which has been recommended. If I take a product of this, the QUP value works out to be 100 kilonewton. The very simple way we can put the values known to us and we can get the estimated value in relation to the system which we are using to drive the pile into the ground. There is no consideration related to soil parameter. Direct empirical relation has been mentioned. Now let's go towards the next numerical. The statement is a reinforced concrete pile weighing 30 kilonewton inclusive of helmet and dolly is driven by a drop hammer weighing 40 kilonewton and having effective fall of 0.8 meter. The average set per blow is 1.4 centimeter. The total temporary elastic compression is 1.8 centimeter. Assuming the coefficient of restitution as 0.25 and factor of safety of 2, determine the ultimate bearing capacity and the allowable load for the pile. So in this case, what he has said, a reinforced concrete pile which is having self weight of 30 kilonewton inclusive of all arrangement required for the shock observation at the pile head is driven with the help of a hammer weighing 40 kilonewton with an effective fall. Means here the effective fall means it